All right, guys, next lesson. Remember, this week we're going to try to do the law of sines and the law of cosines, and then we're looking at next week having some type of quiz. So this is the scenario for the law of sines. It's kind of like the same scenario as the Pythagorean theorem, except it's not a right triangle. You have, say, triangle ABC, and then little a is the side that's across from big A, little b is the side that's across from big B, and little c is across from angle C. So they have to be in the right place, always the same letters across from one another. Here's what the law of sine says. It says if you take the sine of any angle and put it over the opposite side, that would be equal to the sine of any other angle over its opposite side. So it's a proportionality statement. Here we go. It's going to say the sine of angle A over little a. So the sine of that angle over that side would be equal to the sine of angle B over little b, which would also be equal to the sine of angle C over little c. That's your law of sines. Now what we're going to do with it is you're going to be given some of these measurements, 3 of them, and you're going to have to find the other 3. So we're going to look to use two of these fractions to set up a proportion that you can then cross multiply and solve. So that is ultimately what we're going to be doing. I'm just going to write that down. We're going to use 2 of the ratios. So 2 of the 3 of these, depending on what information you're given, to set up a proportion. Then we're going to cross multiply to solve. Okay, that's what we're looking at. Here's the big thing. So like I said, we're going to do the law of sines, and then we're going to do the law of cosines. To use the law of sines, you have to know both of one of the letters. If you don't, then it's going to be a law of cosines problem. So you got to know big A and little a, or big B and little b, or big C and little c. If you don't know that, then you can't use the law of sines. So I'm going to put that here. You must know one complete ratio. So again, what I mean by that is, example, big A and little a. I call that my golden ratio. So like I'm going to refer to that as the golden ratio. So that's going to be our golden ratio. Because you're going to use that to find everything else you need. Okay, here we go. So here's an example of a problem we're going to be looking at. Example 1. Complete triangle ABC if angle A is 58, little a is 10.2, and angle C is 73. Okay. First things first, for any of these problems, I don't give you a triangle. I expect you to draw a triangle. So you have to draw triangle ABC and put the measurements in it. So just draw a generic, like equilateral looking triangle. You can label it any way you want. I'm going to put A there, B there, C there. And now put the measurements in that you were given. I was told angle A is 58, so that'll go here. Little a is 10.2. Remember, little a is across from big A. So that is 10.2. And then big C is 73. That's an angle. And there you go. So again, what complete the triangle means is find every measurement you're missing. So you're going to have to find angle B, and little c. Now I can find angle B right now because anytime I give you 2 angles, if you're looking for the third, you'll always find the third angle by just subtracting these from 180. So I'm just going to take 180 that out. 180, because that's how many degrees are in a triangle. Subtract that 58, subtract that 73, and I get 49. So that'll be this angle right here. Again, that is how you will find the third angle every single time. You won't do law of sines or cosines or anything to find the third angle. You'll just take the two you have, subtract them from 180, and that's what you're left with. Okay, so now I've got to do the law of sines. Now remember what I wrote here. To do the law of sines, you have to know one complete ratio. So one of these three fractions you have to know. So you got to know A and little a, or B and little b, or C and little c. Now if you look at the problem here, I have both A's. So this one's good. That's what I call the golden ratio. You're going to use that to find everything else. So I know my A's, so I'm going to put them in. So I'm going to be able to say the sine of angle A, which is 58, over little a, which is 10.2, equals, and now I'm going to set it either equal to my B's or my C's, depending on what I have. Now, sometimes you'll have a choice, like you do here. You can put it B over B or C over C. So in this case, it doesn't really matter which one you do. Either would be good. Sometimes you won't have a choice. You're only going to have one other measurement, so you'll have no choice of which one you're going to do. So I'm going to stay with B, and I'm going to say the sine of angle B, which is 49, over little b, which I don't know. So I'm going to put a little b here, and that's what I'm going to find. So I'm just going to call that little b. So that's what all your problems will look like when you're using the law of sines. You'll have three that you'll know, there'll be one unknown, and you're going to cross multiply and solve, and then hopefully not mess up putting it in the calculator. That's a big thing. Got to be careful putting things in your calculator. So cross multiply and solve. That means that this times this, so b times that, would equal to this times this, 10.2 times the sine of 49. So I don't want you to actually use a calculator right now. I just want to see the cross multiplying. So b times this means just put the b in front. That would be multiplication. So that's b times the sine of 58 equals this times this. Same thing. I'm just going to put 10.2 in front of that. Okay. Now you got to solve for b. It's a one-step equation. Once you've cross-multiplied, there will just be one step to solve it. So if I want to get b by itself, I got to divide this away, because that would get b by itself. That's b times something. So I'm going to undo that by dividing. So if I divide by the sine of 58 on both sides, these cancel. And now this is what